implicit differentiation. This method is telling me that I have to differentiate both sides of the equation with respect to x, and then solving the resulting equation for the derivative of y, dy dx. We have to always remember that function y is the function that depends on x, f of x. We will not explicitly see the formula for y. However, we have to remember y depends on x, and we're looking for dy dx. That means we have a few things that is worth to remember. In order to differentiate x cubed, for example, of course we're using the power rule, and derivative of x cubed is 3x squared. In order to differentiate y cubed, I will also follow a power rule, 3y squared. However, I have to follow a chain rule, and I have to multiply everything by derivative of y, dy dx. I might use the notation 3y squared times y prime. That's the same thing. But we remember that behind y we have a function we can call inner function, and we're multiplying by the derivative of this. This is a chain rule. And maybe one more example. Derivative of x with respect to x, of course, is 1. Derivative with respect to x of y, it's y prime, or if we like dy dx, if we like this notation. It means please remember derivative of y, it's y prime. Let's start. Exercise number 1. Differentiate an equation x squared minus xy plus y squared equals to 7. It means I will take both sides of the equation and differentiate with respect to x. X squared minus xy plus y squared, and then I will also differentiate with respect to x the right hand side. Derivative of x squared is 2x. Now derivative of xy, we have to remember we have a product rule. Derivative of x is 1 times y. X times derivative of y, it's y prime. Derivative of y squared is 2y times y prime. We remember chain rule. Derivative of constant 7, 0. 2x minus y minus xy prime plus 2y y prime. We're solving this equation for y prime. I have to isolate these two terms on one side, and I will write the positive one first. 2y y prime minus xy prime, and I will add y to both sides and subtract 2x. Now I will factor out y prime. 2y minus x will stay. Copy this side and divide both sides of the equation by 2y minus x. And this is my final answer. And I think it's this one. Exercise number 2. The same thing, different equation. Differentiate y squared equals to x cubed minus 3xy plus 3 with respect to x. Derivative of the left hand side with respect to x, and the derivative of the right hand side with respect to x. Derivative of y squared is 2y y prime. Derivative of x cubed 3x squared minus, and now again we do have a product. Derivative of 3x is 3 times y plus 3x times derivative of y, and derivative of 3 is 0. 2y y prime 3x squared minus 3y minus 3x y prime. We need this quantity and this one on one side, since I'm solving for y prime. 2y y prime plus 3x y prime, and quantity 3x squared minus 3y will stay on this side. Let's factor out y prime. 2y plus 3x will stay in the parentheses, and I have to copy this, and I will divide both sides of the equation by 2y plus 3x. 3x squared was on the right hand side. This is the final answer, and I see this answer in the option B. 3x squared minus 3y, 2y plus 3x. Exercise number 3. The same thing. Let's differentiate using the implicit differentiation x squared y, x, y cube, and with respect to x, the right hand side 8. Both of the terms is product. Please remember to use the product rule. Derivative of x squared is 2x times y, then x squared times derivative of y, minus derivative of x is 1 times y cube plus x times derivative of y cube 3y squared times y prime. Derivative of 8, 0. Let's rewrite 2xy plus x squared y prime, and you probably noticed that's what I did in the 2 previous examples. We have to distribute a negative sign. Negative y cube, negative, and let's make a nice order, negative 3x y squared y prime. I'm solving for the derivative. This means y prime, and y prime is here. I have to keep these terms on one side of the equation. X squared y prime minus 3x y squared y prime equals to, and then I will add y cubed to both sides and subtract 2xy. Let's factor out y prime. X squared minus 3x y squared will stay in the parentheses. I have to copy my right hand side, and I am dividing both sides of the equation by x squared minus 3x y squared, and this is y cube minus 2xy, and I believe this is my final answer. And looking at all of these options, we always have to be really careful. I see my answer in option A. One more thing I could add here, because fortunately my option is the same. Please note that I can switch the order because one numbers are negative, positive. I can put positive 2xy and then negative y cube. This means that I did factor out negative sign. I can also do the same in the denominator. Can put negative in front, 3xy squared minus x squared. Because if I will distribute the negative, this will be negative, this will be positive. That's what is above. Negative and positive. But I will not do this. These two negatives will cancel out, and I might have the equivalent form as a 2xy minus y cube 3xy squared minus x squared. Just in case if you will get this form, make sure that you can rewrite playing with these negative signs. Exercise number 4. Given the equation x squared plus y squared equals to 2x y squared plus 1, find dy dx, but at the point 2, 1. X is 2, y is 1. So now I will use implicit differentiation, but I will take the advantage of the given point 2, 1 and use the point right away. Let's differentiate first. I will differentiate with respect to x left hand side, and I will differentiate with respect to x right hand side. Derivative of x squared is 2x. Derivative of y squared is 2y, y prime. Derivative of 2x, y squared, product. Remember to apply the product. Derivative of 2x is 2 times y squared plus 2x. Derivative of y squared is 2y, y prime. Derivative of 1, 0. Okay, and now, since I don't have to get a nice formula, as mentioned before, I'm using my points. X is 2, y is 1. I'm taking the advantage and substituting them right away. Might use different color. 2 and 1. Let's see. 2 times 2. 2 times 1, y prime, 2, and then y is 1. I can possibly do 2 and 1. Let's see if I can. 2 times 1 plus 2 times 2 times 2 times 1 and y prime. And we don't have to put plus 0. Okay, that's me. Let's see what we have. We have 4 plus 2y squared, 2 plus 2 times 2 times 2 times 1, 8 y prime. Probably you can do this step right away, but I wanted to show you that I'm substituting instead of x and y the given point. And then subtracting 8y prime from both sides, I have negative 6y prime, and subtracting 4 from both sides, I have negative 2. Dividing by negative 6, I am getting my derivative as a 1/3, and this is derivative at the point 2, 1. And that's my answer. That's me. Please take the advantage as I did and use the points immediately. The point immediately. Okay. Almost the same thing, but a little bit of application. Find an equation of the tangent line to the curve xy plus x plus y squared equals to 11 at the point 1, 2. This means we know that the equation of the tangent line needs a slope. That means I can possibly write point slope form. Point slope form of the equation of the tangent line. The point is given, y minus 2, and this is slope, dy dx. Slope means the derivative at the given point, x minus 1. This means the only thing that I have to do, I have to compute dy dx at the point 1, 2. Let's differentiate using implicit differentiation both sides of this equation. xy plus x plus y squared, and then derivative with respect to x of the right hand side. Again, I see product, remember to apply. Derivative of x is 1 times y, x times derivative of y. Now we have inner function x plus y to the power of 2. Derivative is 2 times the quantity x plus y times derivative of the inner function, derivative of x, 1 plus derivative of y, y prime. Derivative of 11 of the constant 11 is 0. And the same thing, I'm gonna take the advantage of my point 1, 2, and I will substitute to my equation. 1 times y, this is just y, and y is 2. I'm switching the colors. 1 is, we have to substitute for x, and then y prime. 2 times x plus y, 1 plus y prime equals to 0. And x plus y is simply 1 plus 2. Let's see what we have. 2 plus y prime. 1 plus 2, the blue numbers, is 3. 3 times 2 is 6, and I will distribute 6. 6